Hello, everyone.
Hello.
Hello, everyone. Good afternoon. Well, it's 5 minutes past the hour, so I propose that we start.
Okay, go ahead, Mario. You want to do the intro?
No, that's okay. Okay, so as usual, this is an official meeting of the IETF, and the meeting is being recorded. And so, by participating to this meeting, you agree to follow the IETF processes and policies. So including about conduct, participants are expected to behave in a professional manner and extend respect and courtesy to their colleagues at all times, and about intellectual property rights, if you are aware, then that any contribution is covered by patents or by patent applications that are owned by you, your employer, or your sponsor. You must disclose the fact or not participate in the discussion, okay? And so you are encouraged to read the source documents to which the note well refers, and they can be found online by scanning the QR code. If you have questions, don't hesitate to talk to the working group chairs or to the area director. Okay, let's move on to the agenda. So as usual, we're going to go through the working group document status. And after that, we will have two presentations. So the first one will be presented by Lorenzo Corneo. It's about sheet pellet compression. And the second presentation from Alexander will be on chic header format and chic shapes. Okay, and in the end, hopefully we will have time to discuss any other business. Alex, do you want to do the document status?
Yes, thank you very much, Mario. It's a little bit tiny, but we have quite a lot of documents. So the work is progressing well. I'm advancing pretty well with the Shepherd write-up of the update of RFC 8824. All the authors confirmed by email all the information that I needed, and I got this information today. I think I'm waiting also for Ivan to answer to the last question, or I think he answered. I'm not sure. But anyway, I'm going to see this, and other than that, I think I'm ready for the write-up, and so the document is ready to ship. And I've also requested an early review from the young doctors for the young data model, and we'll see when that arrives. It's a little bit complicated to work during the day here with all the management of the heat wave. So I'm probably not going to be able to finalize that in the next 1 or 2 days, but definitely like in the beginning of next week. Yes, Marco.
Alexander, thanks a lot for the shepherding work and for your review and your comments. You have a very extensive reply on the list and PR number 1. And then I also sent another shorter mail to the list on 2 small fixes that I described there, for which there is a separate PR number 2 that was about 1 week ago. So absent objections in the next few days, I was planning to submit the resulting merge as version 9, and then you can take it from there. But it's basically about those 2 PRs.
Yes, thank you very much, Marco. Yes, I glanced through the PR request and yeah, I didn't write anything back. Sorry about this, but yes, it responds to the things that I found, and you found some other things as well. So so yeah, I mean the document is seems in really great shape. And yeah, so I'm finalizing the shepherding write-up, and I said I'm going to end it by yeah, beginning of next week, so it can go into it can leave the working group.
To confirm with you, do we need a presentation in Vienna?
I think it's good.
No. Yeah. You tell me.
That's a good point. So we'll start a request for slots in the beginning of next week for the IETF in Vienna, and that's
well, I wasn't thinking to, and if I give one, you'd be what I sent on the mailing list, basically.
Yes. For the moment, maybe not. I'm not sure. I'm not sure. I'm not sure.
No worries.
I wouldn't. Probably a short date of the things if time permits, because it's a wonderful work. So so
we can decide in a few weeks. No, either works for me anyway.
Yes. Okay, so that's great. Thank you, Marco, for all the amazing work you did on this document, and yeah, it's a really consequential work, and I think it's yes. So that's on this document. On protocol numbers, I know that Quentin is also advancing with his shepherding write-up, but probably we are also working on the SCHC architecture. We really want to ship it before the cutoff so that we have the full presentation. And yes, we don't have this actually here. I forgot to mention it. So we discussed with Marion, and we'll be organizing a side meeting. So as you probably saw, the SCHC working group meeting is on Friday afternoon, like the first slot in the afternoon. So yeah, it's not an ideal, but it's a good slot anyways. So we'll be organizing a side meeting somewhere in the beginning of the week, so that we could actually be working on the SCHC architecture. Because like it's almost done. We've really did a great progress, but it's good that we have some corner cases that we'd like to discuss with everyone, so that we so that the work is really finalized. So we'll be organizing this. And yes, so that's all from me. I don't think I have any other points here. So Lorenzo, the floor is yours. Okay, Marion, you're doing the Go ahead, Marion.
I think I need control.
Yeah, I just know how to to do that yet. Alexander, can you help?
Okay. Yes, just do that. It's I'll show you the difference.
Yeah, I think it works. Yeah. Thank you both. Yeah. So this is Lorenzo, and yeah, this is an update on the work that we have been doing on the SCHC payload compression draft. So the purpose of this meeting is that we have been internally working at some major structural changes in the draft, but of course the scope of the work is the same. So about reusing the SCHC framework for compressing also the payload. But before doing and submitting a new version, we wanted to discuss these changes with you and also getting your feedback. So what we want to remove in the next version. So we started the first two versions of this draft by having two types of compression for the payload, one static approach and one dynamic approach. But then when we started thinking about implementers, then it was clear that the normative aspects of the draft were kind of hidden in the methodologies for doing the compression. So to do that, to improve that, we thought that maybe we remove some of this information and we highlight more the normative aspects. And the rationale for reducing this part is that the dynamic approach, as well also, the static approach can be documented in a separate document, like for example informative or even standard track, depending on what is going to be there. And then what are these normative aspects that we wanted to highlight more? So first of all, we would like to propose a new matching operator, which we just named equal template. And of course, if someone comes up with a better naming, we are happy to implement the change. But the idea is that this new matching operator will be able to evaluate equality between field values and the templates that can be stored in the target value. And then, yeah, the matching procedure is pretty similar to the standard one in SCHC, but of course this should be adapted slightly to the use case of payload. And the procedure would be that we parse the template, and then we identify the fixed parts, and we discern them from the variable or functional parts. Let me get there a bit later in this presentation. But the idea is that here you see this very simple JSON object that could be an example of payload, and then you clearly see that there is a fixed part, which is fixed in this case, and also a colon and the curly brackets, and then we have this special character, $sign and variable. So that will be the variable part, and all the rest would be the fixed part. And then of course we can perform bytewise matching on the fixed portion, and we can remove from the matching all the variable parts that are delimited by these special characters or sequences of characters. We are open about that. We can discuss that at the end. And then when all the fixed parts match, then we have a match, so it's true. Otherwise, the matching doesn't happen, and we can go to the next rule. Then also what we are planning to add to the new version of the draft is how we encode the residue for the payload. And here, before we had only this special character and the position in the template, but now we think that we should also add the length. So we will use this notation like special character n, signaling the position within the payload or the template, and the length. And yeah, you can see an example. So the first position in the template could be 10 bytes. Yeah, so the values are supposed to be shorter than declared length, so that you have some margin for extending the length of what you want to encode in the payload. And of course, we can write these values with 0, and then the compressor can strip out this trailing 0 bytes and then just fetch the payload. And the good thing is that both compressor and the compressor know the template and know the length, and therefore there should be any issue in compressing and decompressing the payload once the template is matched. And yeah, also there should not be changes to the basic SCHC rule from the RFC. And then, so this is where we said, okay, we kind of remove the dynamic payload approach, but this feature is what still enables to perform dynamic compression. So here we thought, okay, we can introduce a keyword, like for example, payload, to be inserted in the field identifier. And this keyword can work with a template or without a template. In the case of a template, it is like we have done before. So we encode the template in the target value, and then we do the matching with the equal matching. Otherwise, we do not need the matching operator, but we can still specify payload compression without using the template. So the idea is that we enrich the field identifier with the keyword plus some semantic that can be used for doing compression and decompression. For example, one way to put it is that, hey, we just write a payload as a field identifier, and then we add metadata like column separated metadata. For example, we can add the media type, the group, or the position in an object, and then the field, the name field. So if we translate this into a concrete example, we can have payload, and then we can signal that the object that we are trying to reconstruct is a application JSON media type. We can say that whatever is matched and compressed or decompressed is part of the first object, so object number 1 in our payload, and the name of the field that we want to compress or decompress is ID. And this works very well with key value based format, like for example JSON. And then this is a way for which we can encode payload using both template, but also without template, for example, simpler cases. So far, we have proposed this type of semantic encoding in the field identifier, but so far we have not thought about the fact on whether it should be normative or not. So this is also up to discussion at the end of this presentation. Yes, Alex? Yeah.
Yes, would you like to take questions as the presentation goes, or wait at the end, maybe?
Yeah, it's fine, sure.
Yes, okay. Just a question. So, yeah, I see I see here the dilemma, and I see also like the full structure in the target value. So that's really nice. I have to read the latest version of your draft to go a little bit more into detail about the semantic interpretation, the semantic version of the payload keyword. I'm not sure if this is in any way related to the universal option draft, SCHC universal option. Where there are the two types of, like there is this approach where you can have like a description of the field that you're going to be compressing, and so I think what you're specifying here, it's a little bit, how can I say, not larger, but it's adjacent. It's somehow related to this universal option. I'm not sure if the draft as it is right now, universal option, can cover the case that you're treating here. I'm not really sure. I see I'm not sure, Lorenzo, if you have any opinion on this.
Yeah, so I should check the document you are referring to, because I'm not aware of that. Of course, if it can be, if you can reuse something, of course, I think it's better if than creating something new, right? So
maybe there'll be need for adjustment. I don't think as it is right now, the universal option, that it can encode this type of information as it is today. But that's a thing.
It's something that it can be covered in the universal option, and then we can borrow it. this draft.
Yes, maybe. I mean, Quentin is here, but I'm not sure we need to check, like, just a thought, like it's not something that has to be solved now. It's just like, okay, there is this other thing, you know, from looked from far away, maybe there's something in common. So yeah.
No, yeah, makes a lot of sense. I will check the draft and I guess Quentin can go ahead now. Quentin, we don't hear you.
Yeah. Oh no, I was waiting for the for someone to let me talk. I'm just reacting just on first impression, but I believe that what you're introducing is targeting a different, at least in terms of semantics, it's a different thing that what we're trying to achieve in universal option. Just for reminder, the idea behind the universal option is that protocols are going to evolve and new protocol options are going to appear, and the question is how do we handle that kind of situation? Say, for example, co-op is introducing a new co-op options, and therefore it means that in the data model of SCHC we need to introduce a new name for that option. So we have to track all of the new protocol options basically. And so the idea was that could we somehow introduce the idea that each protocol has a scope, and there is a naming within the protocol. For example, the co-op options has a kind of like a universal co-op option ID, kind of like a unique number that identify each. And so the idea was to reuse that ID from the protocol to build the rules. So I think it's somewhat related. I believe that there's a common idea, but clearly what you're introducing is targeting a different thing. But it seems interesting. So yeah.
Yeah. Okay. Thanks for the clarification. I guess we can perhaps discuss this also offline and see whether we can have it fit in your draft, or otherwise we can. Yeah, because here the dilemma is, so if we make it normative, then it has to be that way.
Yes.
If not normative, then it's up to implementation, right? So it's flexible, and of course it might lead to inconsistent implementations, etc. So I think this is a bit early to decide, but it's something that I wanted to flag because I see.
Yeah, absolutely. Yeah, let's discuss this.
Yeah, thanks.
Super interesting. Great. Thank you.
Thanks. Yeah, then I move forward. And so, yeah, as promised, I will elaborate a bit more on variable and functions. So, yeah, before we had this positional variables that tells you where in the payload the variable part is, right? And before it was only position, so it was an integer, so 1 comes before 2, very simple. And then we had this repetition when, for example, in SNML, you have instances of records. So you might have multiple, but then you can just have one in the template with a repeat function, and then that means that you might have multiple of these. The changes that we are proposing in this new draft is that we use also the length for binding, the length of the variable field. This has the drawback that you might not squeeze it up to the bit, right? If you have, I don't know, 10 bytes, right? And in the repeat, we also add a separator now, because otherwise the compressor might not know how to separate the fields in the reconstructed payload. And also, in order to mark these repetitions, we have to encode the length. So far, we are planning uint and unsigned int 1 byte basic. So maximum value is 255. That might not be enough. So something to discuss as well. Yeah, and here a very quick example. So there is the payload on top of the slide. So what we are doing here is that we can have either, this is how it works, right? So you get the payload keyword, and then we specify the template in the target value. Then we say that we want to perform a matching operation using the equal template newly introduced here. And then here the template can be this repeat, and then we have the fixed part, which is ID, ABC123, and value. And then we have the variable part with this positional variable, number 1, and then we are saying that maximum this field is going to be 4 bytes, and our separator is a comma and a space, right? And the residue is encoded as follows. So we get the length, which is 2 bytes, and then we encode as a string the value of the variable part, which was this -11, and then there is the other 4 byte for 13, because -13, because that is the second variable which is repeated the second time. Yeah, and this is an example without the template. So we are achieving the same thing, but by using this decompression semantics. Instead of specifying a template, we specify 4 field identifiers encoded as I showed earlier, and here we can. Well, here we are also encoding the ABC, right? So here we specify also the ID, and then the value, we just send it uncompressed, and then again we compress ID at the second time with the same value, and then again we send a compressed value the second time. Yeah, and on the other side, the compressor will know how to put together the initial payload, because it knows that it's payload and it is an application JSON meta type, and then the first object is done by this ID and value. Value for ID is ABC123, and then the value is in the residue. And the same thing for the second record. Yes, Quentin?
Yeah, thank you. I wonder if that positional argument, the 1, 2, and etc., cannot be achieved in the same way using the position in the field descriptor of the rules. So basically, you would have a single FID, which would be in that case payload application JSON ID, and that then the positional value 1, 2 could be, I don't know, using the position ID in the field descriptor. Does it make sense?
Absolutely. Yeah. And this is why you already see the problem right here, because so if you make this normative, then yeah, I mean, maybe we can still do it, but we still need to have this 1 and 2. Yeah. Otherwise, you can just pretend, okay, there's no repetition here, and I can encode it value by value, no problem. Yeah, very good point, and I guess this is up to discussion within the work.
Yeah, that would be a nice discussion, because in the position value of the field descriptor, you have the 0 values that says pretty much wherever, but I believe that in most implementation that means that this field happened only once. And then you have the position value, which could be 1, 2, and 3, and 4, and etc., which means that the value is going to be repeated a number of times. And then therefore the question that I might have is this: are you planning to kind of like introduce a template to say this is a number of repetition, and that number is not specified in the rule? For example, you could say my payload is going to be a list of records. I have no idea how many records that will be in the payload, but somehow with a template, I can just say the residue is going to be n time that specific template.
Yeah, that's a very good point. I think it's actually possible, because we are encoding the length of the repetition. So on the other side, you would be able to reconstruct that. And also, if you put some logic in the compressor, you would be able also to infer the numbers of repetitions. And then you just encode it, and it should be fine.
Okay, well.
But good point. Thanks for bringing this up.
Yeah, no worries. Thanks.
Yeah, this validates. Yeah, thanks. This validates even more that, yeah, I'm not fully sure this semantics should be normative, but yeah, let's sleep on it. Yeah, and then also as part of the new version that we are planning to submit, so far we have this specified this n variable and repeat function, but of course it would be cool that this set of tools would be extensible, and therefore we were thinking about IANA registry where new functions and variable can be added if there is a need. I think that would be great. And yeah, so this is just a summary of the proposed changes. Maybe we don't need to go through that one, but yeah. So some reshuffling in the text, but the content is going to be the same. More highlight on the normative aspects, introducing this equal template, matching operator, payload keyword to signal that there is payload, changes in how we encode the residue for the payload, and then adding IANA registry for new template functions and variables. And yeah, here I think we already went through this, at least the most sensitive parts of these questions already during the presentation. And then one last thing perhaps that I wanted to probe the working group for was about working group adoption for this draft. And yeah, thank you. I'm done with the presentation.
Thank you very much. Very interesting presentation and very interesting work. I have like two. One just like a question. At some point, I was thinking about compressing. So because we are only compressing JSON here, right? If I get correctly, or it can be anything.
In this example, yes. In this example, only JSON, but it could be. I think it could be anything that is key value based. So it can be, for example, YAML or even CSV or something that you can. You have this similar structure.
Yes. So one of the things about JSON, at some point, I was thinking of actually defining a function in SCHC that does JSON to CBOR. This is the only thing that it does, like JSON to CBOR and CBOR to JSON is the CDA. So basically, you can have that.
No, yeah, I was actually thinking about this, but you can even have 2 layers of compression, basically. Because once you have the context in the way we are proposing, you can even have another round with CBOR and make it even more efficient. So,
yes, it becomes super interesting. Yes, so I find that work very interesting. And yes, you already presented that during the like a couple of meetings ago. So maybe one thing, and yeah, I see that there is really interested and there is support, and you're working on it, and so I see the clear application for SenML. So maybe there are more general applications for that payload. So maybe I would try asking the people that are here in the room. So how do you feel about working group adoption? Okay, I will start. We have a tool for that. And yes, can you send the link, please? Okay. I'm going to start directly the point. Timer. That's not a timer. Where's the point? It's here. Show of hands. Adoption of. So here it is, like just initial calling to see what are the feeling in the room. We will start an official one after one on the mailing list, just so that we can see like what do you feel? Do you feel that this is a work that needs to be done at the working group? And of course, there will be things to be improved, the things to be decided during the all the questions that you have here. But that's a normal working group.
Yeah, absolutely. I mean, yeah, we plan to work more on this, and we are very open to taking feedback and improve the draft even more. Thank you already for this great feedback.
So there are 7 votes, 7 yeses. Marion, I think that we can take this one. Okay, 8 yeses. So everyone is so this removes all anonymity. But yes, so everyone that is present is for the adoption of the document. So of course we will confirm that on the mailing list. And I just would like to probably ask you a question is, would you like to keep the same name? Because it's like SCHC payload compression, it corresponds to what it does today. It does seem to have a very, very useful use case, which is SNML. So probably think about this. Would you like keep it like this, or maybe would you like to have it like SCHC SNML payload compression, or SCHC JSON payload compression, or like something else, or or we can keep it as it is.
No, it's a very good point. Let me give it a thought. I'll discuss also with my co-authors because, yeah, it's a very good point. Let us think about it, and we can get back to you once we. But we are not, that unflexible. We can even change the title.
I think it can help. It can help your document in the sense that people will see how this does compression for key value JSON. That's something like JSON compression or key value or a YAML or something like. If you find the right word, then people will say, okay, I see what it does.
It's a very good point. Yeah, let us think about it and come back with a maybe new name. Or if someone has, just ping us and we will consider that. Thanks.
Okay. And we will start the working group adoption on the mailing list. Alejandro, Javier.
Yes, just had a little opinion on renaming the draft. Do you hear me properly, by the way?
Yes.
Yes.
Okay. Yeah, so not keeping it specifically for SNML or something else, because yeah, if we can apply to multiple payload standards thingies, it could be good as well.
Yeah, thanks for the feedback.
Yes, that's a good point. If you find like a way to say like, okay, like it doesn't do binary compression, for example, stuff like this.
Yeah, I'm comfortable with key value formats, JSON, okay, but then yeah, give us some nights to think about it.
Yes, so probably so we'll start a working group adoption, and then I need to double check how we did it in the past when we were changing slightly the names of the draft. Was it like before the working group adoption when you submit the 0.0 version, or is it after? I need to double check this one. I don't recall how it was.
Problem, let us know and we comply with the process. But yeah,
okay.
Thank you everyone for the great feedback. Really appreciate that.
Yes. Thank you for the great work. Thank you, Lorenzo. Thank you, Edgar, for being here and for presenting and for pushing the work forward.
Thank you.
Okay, so with this, so I'll be continuing with another presentation. Let me Okay. So I will try to. So I have around 15 minutes, and I will try to fit this presentation in 15 minutes. And the point is that it's a new work that comes actually from all the discussions that we have at the SCHC architecture draft, but also an idea that I had at some point, and I had trouble actually finding how to solve it. So it's a work in progress. So it's like you can take it as really the very first version, and if you have any feedback for that, anything that you would like to, to contribute back or to change or to challenge, you're very much welcome. So the motivation comes from the following thing. Imagine that you have like a special link, a link over which typically we use SCHC. So that could be like an LP1 link, or it could be interplanetary link, like the ones that are in TipTop working group. But it can be just like any GTN or any other type of thing that really have some very special properties, and we use SCHC on that link. So the point is that sometimes, like typically when we develop a software for this kind of links, these kind of applications, like the servers, like the software already knows that, okay, I'm going to be communicating over a special link. I'm going to be communicating over a LoRaWAN link or over some other high RTT link. So I'm going to set up the timers accordingly. So if I have a DTLS, for example, I'm going to set up the DTLS timeout to be, much larger than DTLS over normal communication. And the point is that sometimes maybe there is some misconfiguration in the stack, or maybe the routing doesn't go as like there are some changes of route, so unexpected traffic goes over these special links, or even just like we just didn't know that this happens. So the point is, how would the source of these packets know that something like this happened, and eventually maybe adjust its behavior? So if it can adjust the behavior maybe. So for example, in the TipTop working group, they're working a lot of Quick, and maybe the Quick behavior needs to be adjusted when it goes over these interplanetary links. And the idea is the following. So you have the source of packets, and it goes, to the destination. And whenever it goes over the router that is like the last router before this interplanetary link or before this LP1 link, well, there is some way to see that, oh, this packet is marked. Yes, it is actually intended to go to this special link, so I do nothing. Or, oh, it was not marked at all, so probably I should send a message back to the source to indicate that, hey, this, you are going to be crossing onto like interplanetary or onto an LP1 domain, so just make sure you are adjusted, and maybe the things can be dropped. And so there is a draft I worked on, like it's like a new type of ICMP message where there is a little bit of security to have like authenticated information about this sent to the source, so that the source knows that this information is actually real. And of course, a very simple and straightforward way of doing this is using, for example, traffic class. Say, okay, well, it's a little bit naive, but it can solve like some of the. Yes, thank you, Marco. Thank you for being here. But it can, like, if this traffic class is set like this, then it is supposed to go through. That's okay. And the other point is actually to say, well, we can actually have a SCHC header that is within the traffic, and that specific SCHC header has a specific shape, and we can use this to say, okay, we let the traffic go through, right? And this is the idea is to say, well, how do we say that this specific SCHC header? How do we know the form, the shape of this SCHC header, so that we can actually understand what's in it, right? And so one of the problems is that intermediate nodes, which do not have the full SCHC context, don't want to need or cannot have the full SCHC context. Like the endpoints, they know they have the full SCHC context. They can do the compression decompression, but the intermediate nodes, they do not know this. And so the point is that they cannot even look at the thing and say, okay, well, there is a control header or there is a rule ID, and the rule ID is of this size, and these are the rules. So it cannot know. We cannot have any. It can be used for sometimes for firewall and control access, or maybe even just like for a tool for as a Wireshark, where we can see the traffic. So we cannot really have this. And this is by design. Like in SCHC, we don't have this way of standardized saying. We didn't standardize in the way of saying like the rule ID is always going to be 8 bits, and there's always going to be a control header behind with that many bits, and there's always going to be a data header. Like it's entirely defined by the context, and if you don't have the context, everything is like opaque, right? And so so this is an issue, right? So the idea is to have a new way to describe this. It's a SCHC header format, and basically is to have a registry. Is to have a registry where we can have a named description of a datagram framing. So in that description, we say, well, there is a rule ID. The rule ID is of that shape. For example, if it's of that form. For example, it's a fixed size. It's we don't say how many bits, but we know that it's a fixed size, or it can be like a variable size, and we know how to interpret that variable size. And then we have the rule ID, and then there's maybe a control header or not. So maybe there's a control header, and the control header is before the rule ID or after the rule ID, right? And there is data header, and the data header is at that place, and so on. So that's the SCHC header format, which is this like description of what is there, and then we have the instantiation. It is like it takes the SCHC header format that is there and it actually fixes if there are any parameters. So for example, if we have a fixed length rule ID and no control header, then that's one SCHC header format, and the specific shape is we have the fixed length rule ID with length of 8 bits, and that's like the RFC 1911, like the SCHC over LoRaWAN, where it is specified like this, and we can have like one header format, but many kind of SCHC shapes like this. So in the draft actually it specifies this, and basically what it says is, well, this is the way to define a SCHC header format. There are 3 ways. For the moment, there is a registry to be created at IANA. So for the moment, there are 3 types of rule ID encoding that are defined. So fixed, so that's a fixed number of bits, and that means that any entity on the road of a SCHC packet can go and can look at this and can say, oh, okay, I see the rule ID is a fixed number of bits, and this fixed number of bits is, let's say, 8 bits, so I can go and see this, right? So that's one way to do it. Another way is to have it like self-delimiting, so that means that we know how to interpret it. Let's say the first 3 bits give us the size of the rule ID, and like if it's 3 bits, or if it's 5 bits, then like the whole rule ID is 5 bits, right? And it's encoded. So that's another way. And the third way, which is as it works today, well, it's defined entirely by the context. So there, I mean, it's opaque. You need to have the full context in order to be able to actually understand this. So this is the way our RFC 8724 works today. So this is what is there today in the draft. And then there is a way to say, okay, well, okay, so there is one registry that says these are the ways to interpret rule IDs. These are the ways to interpret what are the control headers are. So 0 for the moment for the moment is none. So we just have the SCHC data header, right? 1 is using voici. So that's the proposal from Quentin. So it's like a multiplexing, and it can use integrity, and it's of 1 byte. And of course, there can be many others, right? And the point here is that, like, you have a registry in which you have, this is the SCHC header format. My SCHC header format, the one that I'm using is, let's say I have a fixed rule ID, then I have a control header, and that control header is voici, for example. Or maybe in other cases, it will be I have voici as control header, and after that, I have the rule ID, and the rule ID is of 8 bits, and then I have the data control header. So that's the shape, that's the fact that it's 8 bits, it's in the shape, right? So that's it. And yes, as I said, so there are like 2 very minimal IANA registries. One is for the the type of SCHC rule ID encodings, and the other is for SCHC control header types. And that's the whole mechanism, right? And the point is that we can actually, so the draft goes a little bit further, and it says, okay, how we can actually encode this this SCHC shape of the thing, which actually can say that, okay, specifically, how can I signal that, for example, in the ICMPv6 message, or maybe in a different type of message, so that I can know exactly how to interpret the SCHC header. And so there are 2 ways that are defined. One is out of band. So maybe there's like just there is a local registry, or like through some way you discover that, and then you can find out this. It can be a configuration, or we can. There is a very light encoding that is written in the draft that basically describes. There is 1 byte to give the number of the rule ID encoding, the number of the control header encoding, and then if there are any parameters for that. And it's like 2 or 3 bytes. So that could be working very nicely with for Wireshark, for example. I have to write an example that is more visible here. Yes, so here we have the SCHC shape tag. So it's 1 octet for 1 byte for the control header type, 1 byte for the rule encoding, and if there are any parameters, for example, the size for the fixed length size for the rule ID encoding. And yes, so that can be part of the voici header. So the type of how that could work for Ethernet, for example, is I imagine that the way to go for this is to say, well, when we have an ether type SCHC, then in the RFC it can be written, well, whenever it's ether type SCHC, then inside there needs to be the SCHC header format must be this, and the SCHC header format must be using voici as control header, and then having like the rule ID of a given size plus the data header. Right? So whenever you're using ether type SCHC, you know how to multiplex things on top with voici, and you also know how to interpret the whole header with it. And the same can work for UDP. If we have an UDP port, we can know that for this type of UDP port, then inside is voici plus the shape of the header. Yes, so there are some things that are not in the draft yet, and these can be fixed later on. So there is no Young model, and some of the things need to be defined. But yeah, that is probably future work to be done. So that's it. I just wanted to present it for today, and my feeling is that this can be like a standalone document, and there could be a very light reference from the SCHC architecture, and this separation. So we need to see if it stands the time, like SCHC header format, SCHC shape. Maybe it should be changed, the naming. But the point is that in this way we can. I think that we can solve this question, which is how can in some cases understand a little bit of the structure of the SCHC header, even though classically SCHC was like, okay, you need to have the full context. So thank you for your attention, and yes, we're almost at the top of the time, but if you have any questions, don't hesitate. Okay. Yes, Alejandro?
Thanks. It's very interesting. I just didn't really understand So I got the problem, and
Yes.
it's what happens when a SCHC packet encounters a node that does not do SCHC. What you want is to be able to route it properly, like to send it through the right node. Like this node, which does not know SCHC, must know where to send it anyway.
Yeah, I mean, it was so the very actually here I presented two things. The first thing is why we did it, and the second thing is the actual doing it here. So the idea was the first was if I have to simplify, is to say, imagine that you have a router in the middle, and there is some SCHC traffic that goes through the router. So let's say there it's IP UDP, and then inside there is in the UDP there is like a reserved UDP port for SCHC, and then you have like SCHC traffic. Because SCHC is, you need to have the context to be able to parse it, to be able to understand it. You don't know what is the size of the rule ID. You don't know what headers are inside. I mean, you don't know anything. It's just like zeros and ones. So the intermediate router, they are only going to see like IP with UDP port. I don't know if we get allocated, let's say UDP port 2000. They are the only thing that they can see. The intermediate router can see, and so if they cannot do anything with that, they can say, okay, well, I'm just going to be dropping this packet, this traffic, because like maybe it's a security breach. So we need some way to be able to tell these intermediate nodes, to tell them, okay, the structure of what's going through here is this. So there is a control header. The control header is like multiplexing streams like this, and maybe there is a rule ID, and the rule ID is of that many bytes, of that many bits. Maybe there's some context ID. I don't know. Like there are parts of the information that you can go and that the intermediate router can go and can analyze, so that it can say, okay, well, I see what's happening here, so it's a safe traffic. I can let it through. And this SCHC header format is basically the way to say through a public registry to say the first that many bits, it's this protocol, it's the control header. Then the next that many bits, it's the rule ID, and then the rest is like the data header plus the residue. So even if the intermediate node doesn't have the full context, it can at least go through some security checks or through some validation to see, okay, what's happening here is according to my policy. And they don't have to do full decompression. Like they can only go and see, okay, well, this type of header, okay, I understand. This type of rule ID, I understand. That's okay. I allow rule IDs from 1 to 20 for this type of traffic, so it's good for me. I'm not sure if that clarifies a little bit or not.
Okay, yes, it's a bit clearer. But yeah, I'm not sure. I think I would have to check how routing is done in this case, like in these specific cases, because usually a node that does not do SCHC doesn't really care about the SCHC payload; it just forwards it, no? And the IP, like the IP address and the UDP port should be enough to like forward it. And then if there are like security rules or so from certain traffic, then I'm not sure this is up to SCHC.
Well, I mean, you're right, but the point is that, okay, let's say another example is, so I think that the security is the strongest one here, because you still may want to write some firewall rules that go and forbid some, okay, it's SCHC, but if you don't know anything more than this, you can say, okay, I forbid all traffic, because it can be used to tunnel or to do some nasty stuff, right? It's as in some cases you have some, some firewall rules. They say, okay, we forbid UDP traffic, like this in the past. We forbid all UDP traffic because we cannot. It can be used for bad stuff, right? So you can have stuff like this. Okay, we forbid all SCHC traffic because that it could be potentially some kind of it can be a malicious traffic. In this way, you can actually go a little bit further, and you can tell the network, hey, well, okay, it's a SCHC, but also this is a structure, so you can write more specific filtering rules on that. As I said, like the rule IDs are all 3 bits, so like you can enable so that the administrators can say, okay, well, we allow all rule IDs that are from that are over 3 bits, right? And if there's something that comes with rule IDs of 4 bits, like it doesn't work. It's we need to filter that. Or we can have like a Wireshark module where you have like the SCHC traffic, and the Wireshark module cannot understand anything. It's just zeros and ones. Like with this mechanism, the Wireshark module can go and can understand that. Oh, okay, well, I see this, and I can go and I can look inside the SCHC packet, and I can say, okay, well, there is a control header. The control header is with this protocol. Let's say voici, and so forth and so forth. So we're a little bit behind the time. I will send. I probably will be working a little bit more on the draft and try to send a little bit more information on the mailing list, and probably we'll have another discussion, before the IETF and hopefully at the IETF. Thank you very much, Alejandro, for the question. So for questions, and yes, thank you, Edgar. Thank you, Quentin. Thank you, Marion, for being here, for staying.
Thank
yes.
you for participating to the meeting today, and don't hesitate to continue on the mailing list.
Yes. Thank you all. Bye.
Bye-bye.
Bye, thank you.